And today we have a special guest, Scott Hogg, who is the CTO of GTRI, and he is going to be talking a little bit about AWS security best practices and also just best practices for security on clouds in general. So I'll turn it over to you, Scott. And as a reminder to everybody else, please stay muted. And if you have questions, use the chat room. So take it away, Scott.
Oh, thank you. Yeah, I'm Scott Hogg, CTO of GTRI, based in Denver, Colorado. Our company, GTRI, will be changing its name to Zavaro in the next several months, so you may also see reference to that name. I've been in IT and security for a lot of years, and I've been interested in cloud security for a number of years, getting my CCSK from the Cloud Security Alliance and my CCSP from the ISC Squared, as well as a number of AWS certifications. I'm up to like 6 AWS certs now. So worked in AWS for a variety of customers for a number of years. And so I wanted to share with you today a roll-up presentation of many of the AWS security best practices, and then show you a live demo of a working AWS account with many of those practices in place. And hopefully you find this very useful. Hopefully you can put into practice, into production, these recommendations of best practices. And maybe you're doing all of these things, maybe you're doing some of these things, maybe I give you some advice that helps you be a little bit more secure in the cloud. And so with that, we'll proceed. So I think you might be already familiar with this concept of a shared security responsibility model, where in the cloud you bear responsibility as a cloud customer. The cloud service provider bears responsibility to keep that infrastructure up and going. Depending on the type of infrastructure as a service, PaaS as solution you've purchased, the responsibility model may change. You know, if it's simply software as a service, the service provider bears more responsibility, but the customer is ultimately responsible for, you know, the confidentiality of their data, who has access to it, and what have you. In infrastructure as a service, a customer would bear more responsibility. They're responsible for down into the operating system layer, patching, vulnerability scanning, access controls, all of their software security. They have a lot more responsibility. And that's important to keep in mind. And there may be a gray area, like there may be a company like GTRI that may be providing cloud managed services, and you may be relying on that provider to provide some security. And so the responsibilities matrix is really important to have defined among all the security controls. What are the security features that the cloud security or cloud provider is providing, like infrastructure security, security of their hypervisor, destruction of physical media, physical access to the data center, you know, what a cloud service provider might be providing you, a cloud managed service provider, an application development group, and what have you. Breaking those down is pretty important, and that's kind of the first step. When you operate in Amazon Web Services, they have a slightly different AWS shared responsibility model. Now, in general, you know, when it's EC2 compute, you know, you're responsible as a customer for everything on top of that, that EC2 instance. So the operating system, the security of that operating system, and everything above that. But depending on which AWS service you use, the responsibility is different. If you're using a RDS managed database service, you're just responsible for the security of access to your database. AWS is handling all the patching and so forth of the database service. So depending on what service you purchase from AWS or are using, the responsibility model may change, and that's important to keep in mind. Of course, AWS has many compliant certifications and accreditations. That's helpful, but these accreditations are really just for them and their infrastructure. You would have to then apply these layers. If you had to meet, PCI accreditation, for example, then you would have to handle everything in your infrastructure as a service on top of that for PCI. But at least you would know that the data center, the facilities, the hypervisor is being supported by AWS. So in other words, it's kind of their responsibility, and there can be finger pointing. So it's important to have that responsibilities matrix defined right from the beginning. And there is concerns about AWS security when you operate in someone else's virtualized data center. And you may not know exactly which physical data center you're in. You may know you're operating in a region and an availability zone, but where is your data may not be something you could put your finger on. And there have been many examples of breaches where organizations who have been operating in AWS who aren't following many of the security best practices can end up with data breaches, outages, attacks, the resources consumed, and so forth. So it's really important when you're operating in an environment like AWS that you have all the best practices ticked off. And as they say, you're only as strong as your weakest link. So you want to make sure you have thorough, comprehensive, complete set of security controls when operating in a cloud environment where you can't physically surround your servers like you do in an on-premises data center. So we'll talk about the AWS specific security services that you can leverage to help you operate in AWS more securely. Identity and access management is a key pillar to information security. And that's actually a must. You want to have, IAM policies for users, groups, and roles, and apply those least privilege methods to those users. IAM users can have access keys and secret keys that they use when programmatically interfacing with the AWS infrastructure or for API calls. Security token service can be used to grant for a very short period of time credentials to a system, an instance, a piece of software based on authentication. And so you can have a role or a privilege set applied to an instance. So you don't have to put shared credentials or passwords into that instance. The instance has only access to access certain types of functions, like the instance has only the access required to fetch objects off of an S3 storage bucket, for example, or access key management service key to then decrypt elastic block storage, EBS storage volume, for example. So you shouldn't be using kind of the root privileges in your account to provision any resources. The root is just there for, kind of adding your first couple of users. And for billing purposes, you really want to have individual accounts for individual IAM users. And really rely on multi-factor authentication for, not only root access, but all of your administrators and key users, key admin users. It's also possible to do federated identity access with Active Directory or other methods to federate identity access to AWS, not just for system administrators, but for users that may be using the applications in the AWS environment. Another funny cartoon here. Okay, so in terms of the operating system, you're responsible for the operating systems, the hardening of that operating system, and all the software and layers that reside on top of that. So you can take a base, EC2 AMI and build that yourself, and then harden that per your particular STIG guidelines. You can, import in your own image for a particular operating system that you may use. You can harden the operating system before you upload it, or take a base operating system and then apply the STIGs to it using an automation method. There's a variety of ways to do this. Of course, you don't want to store, secret keys in those instances. You don't want to share those instances out publicly, unless that's your intention. But definitely, if you shared community images, you wouldn't want to share those with any credentials in them. That's how some breaches have occurred. You can rely on AWS Marketplace to procure pre-STIG operating systems if that's what you want to use, or your security teams allow that. That may be a good way to use, but you pay a few cents per hour for that process. And it's my opinion that there's many ways to STIG your operating systems yourselves using automation and save yourself some money. Okay. Virtual private clouds, VPCs, are the way you create enclaves or secure computing environments inside of your AWS accounts. VPC includes all the virtualized networking to kind of isolate subnets and virtual routing, NAT and gateways and proxies, and you can put your sensitive applications and databases into multi-tier architecture inside of a VPC to limit internet access to those systems. So really only the web tier, for example, has internet access. You can also create a VPC design and architecture such that you create enclaves within those enclaves, where you have a VPC just for the web interface and proxies. You've got a VPC for the backend management access, and then you have VPCs for the private data application tier, database tiers, and that's kind of the meat in the middle of the sandwich, and doesn't have access to the internet in any way, shape, or form, or only has access to the internet through an outbound proxy that may be a squid proxy that would control access to secure repos or something like that for patching software, for example. Inside of that VPC, those subnets can have NACLs, as we call them, access control lists, that are kind of inbound and outbound stateless ACLs to control access to certain other, IP addresses or subnets. You can have security groups that are applied to an instance network interface, and those are stateful. They generally restrict access inbound to the instance, but allow everything to leave that instance. Every outbound connection is permitted, but inbound connections are restricted. You can have nesting of security groups and self-referential security groups, and you can use a lot of software automation, configuration management techniques to maintain these security groups so that you have really minimum granularity that's required to allow these systems to function and to allow them to access each other and allow users to access the applications on them. So you can get pretty good security at every level of your enclave or of your virtual private cloud by using very specific security groups. You can also operate in the cloud with very weak and open and loose security groups. If you don't have that diligence and the detailed approach to creating a least privilege environment, you could create an AWS environment that is very open and very porous and has vulnerabilities as a result. You can put different systems, as I've said, into different subnets and availability zones and create that enclave, that orbital security model, kind of that onion security model, where the data and the core key applications are at the center, surrounded by layers of other security controls. And you want to document well how this is all set up. And if you use the configuration management method, those configuration files, those scripts, those JSON, those YAML files that are used to build this infrastructure can kind of be self-documenting in a way. But because this is a lights out data center, you just can't go to the data center to trace cables and create a Visio diagram. You want to be very careful about the logical configuration and documenting this so you understand your security attack surface, if you will. AWS VPCs have flow logs, so you can capture logs about packets going in and out of network interfaces, and you can log that kind of like you do with NetFlow today. And that can be, that VPC flow log data can be used in deeper analytics as well of traffic entering and leaving your AWS environments. You have a variety of options for AWS connectivity. Of course, you have direct internet access to systems that have elastic IPs and public IP addresses. You can create a VPN, to an IPsec VPN into your systems. You can create other types of overlay networks using these public or private IP addresses as well. And you can use Direct Connect if you're exporting a lot of data, typically from AWS. It might make sense to use Direct Connect to save some costs, but you have to be really generating a lot of traffic out in the outbound direction of AWS to make it worth the cost to get a dedicated gigabit per second connection into your AWS environment. But if that's the nature of the type of work you're doing, it could be useful. Direct Connect, though, as a physical link between a Direct Connect service provider and your AWS VPCs, isn't secure, though. So you may use a Direct Connect, but use a VPN on top of that Direct Connect to ensure confidentiality and authenticity of your connections. You can use Direct Connect with a VPN as a backup, potentially, since Direct Connect is a single fiber connection and doesn't have any inherent redundancy. You may need to back up a Direct Connect with a VPN. Speaking
Hey,
of,
Scott.
Yes.
There was one question, actually there's two questions now that I think we should address before you go a little bit further here. Okay. The first one is there a way to capture user authentication, authorization, and accounting in a VPC?
If those users have IAM credentials, you can definitely create an IAM credentials report. See who has passwords, who has what role, who has what policy, who has what access keys. You can create a credentials report if they are IAM users. If they're users that you have placed into Active Directory and you're maintaining Active Directory servers in your AWS VPC, then you have to look to Active Directory, or if you were doing LDAP or something like that, you'd have to look on those specific servers. You can also be doing web identity federation, so letting authentication to Facebook or Google then allow end users access to a particular application. That's another method, but you can get those statistics and those logs about who's authenticating to a system. So there's a few ways to do that.
Okay. And the second question that just came in was, what about IPv6 support in the IGW, EO, IGW, and VGW, and in VPCs in general?
Okay. That's a great question. That was the last presentation that I gave to this group back in, I think it was May or June. I gave a talk on IPv6 on AWS, where I talked about all the IPv6 specific details of AWS. What services support IPv6, and we went into detail, and I showed a lot of automation of AWS IPv6 virtual networking. So I'd refer that person to those. But yes, and then I've also written a few blogs on that subject for Infoblocks and other organizations. So seek those out, or send me an email and I can get you that information, the presentation, and some scripts I've publicly shared on that. But the answer is yes.
All right, thank you.
Yes. Okay, thanks for the questions. I'm trying to just show my slides here, so I'm not watching the chat, so I apologize, but thanks for bringing up those questions as they come in. In terms of backup and disaster recovery, I mean, you can use AWS as a offsite DR. You can back up data and instances between availability zones and regions. You can make snapshots. You can make Amazon machine images from systems that are running and move those to another region to instantiate a new system as a part of a recovery process. You can, S3 is kind of the default system that's used for storing a lot of these objects and backups. You can set up versioning and other methods to keep you from losing data. You can have MFA delete, so it requires you to enter in your MFA token to delete an object on S3. So there are lots of safety nets that can be used. Of course, you pay for the data storage that you're backing up, so you may not want to continually be backing up information. You delete the oldest versions and keep the newest versions, for example. But there are definitely ways to do this easy in the cloud. Another thing about the cloud, I mean, you may think, oh, the cloud is more porous or less secure in some ways, but because of configuration management and software-driven practices, the operations of cloud infrastructure can actually be more secure than on-premises environments, because you treat them just as a utility, and you can bring them up and patch them more easily. You can patch them in real time or back them up, or use software to perform that process where maybe you don't have the ability to get change control approvals to patch an on-premises database that's shared among multiple apps and needs to be up and running all the time. Having pools of resources where you can kill them and restart them, treat them more like a utility, can be a benefit when operating in the cloud. I used to bury my bones, now I just upload them to the cloud. That's his DR strategy. You can also encrypt the data, and that's the best practice, because when you put your data into a cloud service provider, that could be your exit strategy. If you exited that cloud service provider and you didn't encrypt any of your data, well, where is your data? What hard drive is it on? In their data center, in their virtual data center. So if you left a cloud service provider, they had your encrypted data, that's less of a risk, because as long as you're maintaining the key and you take the key with you, it's kind of like this concept of crypto shredding. You know, if you delete the key and it's just a bunch of encrypted ones and zeros out there, nobody can get access to it. You've essentially, like, you've deleted it. So that's one way to maintain not only confidentiality when it's at rest, but it's part of your exit strategy from the service provider. You can have server-side encryption that AWS manages, but you can also maintain the key. AWS has a key management service that we use quite frequently in our AWS accounts and accounts that we maintain for customers. You can have a customer master key that you can rotate or delete, and you're in charge of it, but then you leverage AWS to perform the encryption. If your security compliance requires that, AWS also offers cloud hardware security modules, where there's a physical piece of hardware in their environment that contains the key and stores that. And that is an expensive way to go, but if that's what your software security compliance requires, that's an option. Now it's priced per hour, where before I think you had to commit to a longer term and it was more expensive. An AWS certificate manager is an easy way to manage a certificate authority for public certs in AWS. I'll show you an example of that later.
Hey, Scott, I'm going to jump in one more time. We've had another question. Are there ways to do backup and disaster recovery for applications and do it in an application consistent way? For example, can we do a backup and recovery for a MySQL database on an EC2 instance?
Yeah, in fact, if you're doing AWS RDS, there's constantly database backups being made automatically for you as part of that service. It's one of the nice things about using RDS in a multi-AZ environment. You get the high availability of having a database service that's split across 2 availability zones by default, making it highly available, but then you get backups and so forth automatically. If you did run your own database on an EC2 instance, you can use any traditional backup utility that you're familiar with that matches your operational practices. So if you're used to doing backups a certain way on premises, I recommend using those same methods when you operate in the cloud. You wouldn't want to have two different operational models, one for on-premise and one for in the cloud. You'd like to leverage the skills and capabilities of your staff to do backups, use whatever is natural, but I also advocate using the built-in AWS tools because many times they're free and easy to use. You just pay for the data storage, but let's say in S3, which you would be paying for anyway, even if you used your own tools. So yes, there are many ways to do that. You can do it at the instance level. You can back up just the database information. We've got a wide variety of options there. And another funny cartoon. You can have a web application firewall service. You can put your own web application firewall on your own EC2 instances. You could procure one off of the AWS Marketplace. You could use the AWS managed web application firewall service and either use a set of managed rules or a set of a subscription that you pay for that pre-populates, let's say, poor reputation information to prevent connections from IP addresses with poor reputation, for example, from any of these companies. Or you could use the WAF security automations, CloudFormation templates that are freely available. There's OWASP best practices as well that you can implement for protecting your web tier. And there's DDoS mitigation methods in AWS. One method is simply just to absorb the attack and scale. There's infinite scale in AWS. Well, near infinite scale, right? You would pay for that infinite scale if you used it. AWS provides some DDoS protection measures, like AWS Shield, which is a free service that every account gets. If you needed more advanced service for DDoS mitigation, there's AWS Shield Advanced. And some of AWS's services have built-in DDoS protection measures. Like when you use an Elastic Load Balancer, for example, or CloudFront Distribution, it's their CDN service, automatically blocks connections from bad IP addresses or blocks connections from fake or spoofed TCP connections or SYN flood attacks or things like that. Route 53, their DNS service can absorb many types of flood attacks. So some of their services automatically have built-in DDoS protections for them. Getting visibility when you operate in the cloud is pretty important. You may lose visibility in some ways because it's not something you could physically put your finger on, but so it's kind of the ultimate lights out data center. So you need to be watching for what's happening because no one's going to be there in the data center to tell you about it. So you need to log all the things, as they say. So you can have a lot of logging taking place inside of the AWS environment. You can use AWS config rules that monitor your inventory. You can use AWS CloudTrail to log all the API activity in the account, and then look through that for any administrative configuration changes that may be occurring. Trusted Advisor gives you kind of a dashboard of what's operating in your environment, some of the best practices for cost or security. Amazon Inspector is an agent you can load on your instances that will perform vulnerability assessments. EC2 Systems Manager can help you keep your systems patched and provide some automation if you don't already use tools like Puppet, Chef, or Ansible. CloudWatch logs give you visibility to your services, not just for performance and metrics, but can also tell you events that get triggered based on rules for certain conditions that you look for. You can configure these to watch for certain security events and then be notified when those happen. I mentioned VPC flow logs, kind of give you access to what's coming and going from your VPCs and network interfaces. Macy is an AI-powered service to look for PII stored on your S3 buckets. And then AWS is also watching your environments. I mean, it behooves AWS to kind of help their customers be more secure and watch out for them. If AWS can provide kind of some automatic observation and remediation and intervention to attacks on their customers, it helps their customers maintain their AWS service and keeps AWS out of the news. So AWS does watch things kind of behind the scenes for you, and you will get notifications. For example, if one of your instances starts performing vulnerability scanning of other instances in your VPCs, and you haven't gotten permission from AWS to perform that activity, they will let you know in a matter of minutes that that activity is taking place and try and figure out if you've done that or if you need to ask for permission for that, or if it's something bad that's taking place in one of your accounts. One of my favorite cloud security cartoons. I just saw my spreadsheet on the Weather Channel. And then there's there's a large AWS security ecosystem where there's a variety of services and software that you may already use in your environments today. And if your operational model dictates one of these security vendors, you could use those same security packages, security functions, security controls in your AWS account. You can deploy them yourself with your own license on your own EC2 instances, or you can procure them through the AWS Marketplace as either a license included or what have you, or a little trial license. Using some of these security marketplace services and utilities is a good way to try something out in AWS. Use it for a few hours and then delete it. You only paid probably a few dollars to test it or trial it, where it would have taken you more, it would have been more of a commitment to test this in your physical location. Equipment or licenses would have had to have been shown up at your doorstep or what have you, and applied and configured. But it's very easy to test things in AWS for just a short period of time. You only pay for what you use, and that can be low cost. Okay, so I'd kind of like to share with you a live demonstration of AWS. I'm going to show you an account and some things running as examples of what I've just spoken about. I kind of have this saying here, no amoebas. Many organizations start out using AWS using the default VPC, and they don't have a defined structure to their VPC, so their VPC is quite porous, and the public IP addresses of their instances is used not only to provide services to the internet, or to connect to other instances, but also for management access. So it has quite a lot more security attack surface than maybe what they intend. So I often advocate using the NIST CloudFormation templates as a way to provide some structure to separate out the web tier from the management tier from the app tier and break that up a little bit. You can also use kind of scriptable infrastructure and security as code using some of these methods. You can use the AWS Management Console, and today I will show you a lot of things running in AWS Management Console, mostly just for visual verification of how it's operating. That's not necessarily how I set it up from the beginning. I use a lot of CloudFormation and Ansible playbooks with Photo 3 to configure things in AWS, and AWS CLI. We'll see some examples of that today. If you're automating, you can automate not only the configuration, and you can have some documentation then of how things were set up. It's also a way to check the compliance, and other people can audit those scripts to validate how the configuration is set up. Also, you can use those automation to just run the automation again, and anything that changed from the baseline that was the validated script would be updated automatically. So that happens on occasion where we'll use scripts to do something. A customer might go in and make a modification. The next time we run the script, it overwrote the manual configuration that wasn't put through the proper authorized process. And so it's a way to kind of make sure that only things that are in the scripts is what's being implemented in the account. So, you know, another example of how you can use, how you can do version control or operate securely in the cloud. Let's say you have a load balancer here in the middle, and it's bordering two availability zones for a web tier, let's say. And we start out with a certain version. We create an auto-scale group that has two instances in it initially, because maybe we don't have a lot of volume here. As the scale scales up, we can scale up new instances with a new version. A new version of our application is rolled out. We scale up, and then we kill the old versions. So we're running a new version, and we've scaled up because maybe we have a scale-up event. Maybe we're doing something related to hurricane relief, and we need some dynamic scaling of instances, compute instances to do something. Then let's say we have an even greater need for scale. We add more, but maybe a new version comes out, so we have systems that automatically patch themselves. Then after the event has taken place, we scale back down. What's left is the newest version of the software running in the minimal HA configuration. So using software automation, auto-scaling, we can create a scenario where our software is constantly being patched. It's scaling with offered load and minimizing vulnerabilities at a very public interface to the internet. So an example of how you can do cloud security through Elasticity. Here's the account I'm going to show you. It has a management VPC, it has a production VPC, it has V4 and V6 in it. Of course, why wouldn't you do both all the time if you had the choice? So you'll see a lot of V6 addresses here today. You'll see some V4 addresses though too, because where I'm connected today, I'm on an IPv4 only network, unfortunately. But I'll show you kind of a web tier. We have an app tier and a management tier. So instead of an amoeba, we have a higher order life form like a human with a skeleton, with some bones, with some structure, with some defined, egress here. So this is like the account that I'm going to show you. Okay. So let me stop that. So let me show you. I started this account using the NIST CloudFormation templates, and I ran those templates, and it created VPCs, logging, production, all kinds of stuff. I used the standardized NIST framework templates. You can find these quick start templates on the internet. AWS makes them available for free. There's templates for NIST or HIPAA or PCI. They're all somewhat similar, but you can launch these quick start templates. And it'll launch the CloudFormation templates in your AWS account. What also comes with these CloudFormation templates, either in YAML or JSON format, is a security controls matrix that I mentioned before. So all for free, you can get this infrastructure I've just shown you that separates out management from application from production, automates the deployment of that, builds those best practices, and then gives you a security controls matrix that will map those security controls for that compliance program to the CloudFormation templates you just ran and those controls, and define what AWS is doing and what your responsibility is. So a pretty valuable place to start and helps you avoid just becoming an amoeba. So here's evidence here that I ran those CloudFormation templates. You can see the different templates that get kicked off. In this account, what's resulted is a set of VPCs. There's a number of VPCs that are created in this region. I'm operating in Oregon. You can see that these VPCs have V4 and V6 addresses in them. And I have subnets, a variety of subnets. There's application subnets, there's database subnets, there's a whole tier of these, application management, production, different VPCs running v4 and v6, and I can put specific instances into specific subnets. I have route tables that define who can talk to who. I have internet gateways and egress-only internet gateways for the v6 prefixes. I have a couple of NAT gateways as well for the different v4 NAT that has to take place. I have network access control lists and security groups. I have a set of security groups here. I also have some automation taking place where if I go in and I make a change to a security group, it will automatically correct it and revert any security group changes. So here, let me go in and make a change to a security group here, and we'll see that this takes effect. It takes a minute or so, so we'll go ahead and edit. So I'm going to add a new rule to my security group. I'm going to allow DNS from 1.1.1.1/32 to my system. Just create a little rule here, automatically allowing DNS to my system, which doesn't make much sense because it's a application load balancer. Okay, so let's see what else we want to show you. So I have a set of VPCs. I have a couple EC2 instances here. I have different security groups. I have a target group, and I have load balancers. I have an application load balancer, a dual protocol application load balancer that's listening on 80 and 443. I'm using 443. I'm using a certificate provided by AWS Certificate Manager. So I have a certificate here was provided by ACM for www.hoggcloud.com. I can go to ACM, and I can see I've got a wildcard cert, and I've got one specifically for www.hoggcloud.com, which is a domain that I have running at a Route 53. So I have some wildcard certs. If I come over here to www.hoggcloud.com, I see my IPv4 address, and I see my funny picture here. And if I click on the lock, I see that I have a certificate that's validated by Amazon, and it's good for a year. You can see the details of the AWS cert. Okay, so that's all running. I'm also in here, in this application load balancer, I'm also running a web application firewall. So I'm logging the access logs to an S3 bucket. I'm also using a web application firewall associated with this application load balancer. So I can go and look at this WAF security automations. I've used the AWS CloudFormation template to automatically build a web ACL and rules associated with this, and I've applied this to my my application load balancer. So I have a web application firewall in front of my my ALB as well. I have a variety of different rules here, and I have whitelists and blacklists. I have reputation lists and things like that. If someone connected to my box, I have this bad bot link here that I've added that is being used to look for bad bots going to my website. So if I was to click on that link and refresh, if I clicked on that link and refreshed, you could also see, 403. So I might be in a penalty box right now. So if I come back here and I look at the rules, I look at the IP addresses that the rule has blocked, and I see this IP address. And this was my IP address, I think. Go back. Yep, what is my IP? 12.209.68. I can see that I'm in the penalty box. So if I go in here and I edit the rule, or go in here and check the list and remove that block from the list, I'll delete my bad IP address. Now I should be able to get back to that web page. So it kind of blocked me because I was doing some bad things to the website. Okay, so this ALB talks to an app server and an app tier. So the web server that was running that page is at the app tier of my architecture. It's not at the web tier. So no one can get to that app server directly from the internet. It doesn't have a public IP address. You can only get to it through the application load balancer and through the WAF service. I do have an EC2 instance that's directly connected to the internet. It's called web.hoggcloud.com, and it runs at this IP address. Of course, we have a funny picture of IntServe here. I want you to use IPv6, and I'm using Let's Encrypt on this. So you can see I have a Let's Encrypt certificate for this system. So you can roll your own. You can use, Apache, Mon Security, other WAFs, or you can use something that's provided by AWS. Okay, so I have VPCs, I have VPC architecture, I have EC2 instances, I have a separate segregated management plane, I have AWS Certificate Manager, I have security groups, I'm using the NIST CloudFormation templates. So I'm doing a variety of things here pretty well. From AWS, there's a variety of other, well, I have S3, I have a couple of S3 buckets. I have S3 buckets that have versioning. I have S3 buckets that have versioning and have default encryption. I'm using KMS. I'm using a key management service, so let me show you that. Under Identity and Access Management, we go in here. I got all green checkboxes. I'm using MFA on my root account. I've created individual users. I'm creating a password policy that meets compliance. I've got users and groups and roles and policies here defined. And I've got green checkboxes all the way here. That's a good sign. Under encryption keys, I have, in order again, I have an encryption key here that I'm using for EBS encryption and other things like that. But I'm using this key for encrypting my S3 buckets and objects in my S3 buckets. So if I look on my default encryption for this bucket, I'm using AES S3 default. I was using KMS. Let me see. In this bucket, I have an object. AES, you can see the SSE, the server-side encryption that I'm using for these objects in this bucket. Let's see. Here's one I've put up here. Oh, AES 256. I thought I was using some here that were using KMS. No, mostly SSE AES 256. Okay. But I have KMS running in this account. And that's the key. And then you can control who has access to the key and whatnot as well. Okay. Then I have S3 buckets, and these S3 buckets aren't necessarily public, even though in the name it says public bucket. I also have a script that monitors public buckets. So if I go in here and I make a bucket public, I create a bucket and I make the bucket public, I have a policy that goes out and checks for public buckets and reverts their security. So we'll watch that. Actually, let's go back to the security group we created. We made a modification to the security group where I allowed DNS from 1.1.1.1 to my security group. And now we go look at the security group and it's fixed. It fixed itself. I have inside AWS, I have a system running, CloudWatch running. I have a dashboard here that tells me kind of bad stuff that's happening in my account. I see some things here that might need to be investigated. I have CloudWatch rules, and this is this revert security group rule. And based on changes to a security group, it runs a Lambda function and will put things back. Then I should also get an error message. I should get an error message, not from Cloud Checker. I should get some notification here. Maybe it'll take a minute here. So we'll wait just a little bit. I should get an email, but this is the function that put that security group back. I also have another function, another CloudWatch rule called config found open bucket, which also runs another Lambda function and subscribes to a config topic, which notifies me if I have an open bucket. Let's go back. Let's see if it changed anything. It takes a few minutes for the logs to go through and get updated, but it should revert itself here at some point. Maybe we give it a little bit longer. But I have CloudWatch events. I have CloudWatch logging taking place. Lambda functions watching logs that are coming in from CloudTrail and config logs. And based on those, it's taking action, kind of what we call event-driven security. Let's see if I have some new logs here. So here's an event that I got. It says S3 public read prohibited. So it saw that I had a bucket that was non-compliant. And here is the log of my Lambda function, which put it back. Okay, so now let's go and look at S3 access. Refresh the browser page. Okay, now we see here that now no longer is the bucket public. It's not public anymore. So it corrected itself. So now this bucket, which I made public, is now not public. So an example of how CloudWatch is watching the environment and taking action on a misconfiguration that violates my policy. And I had a security group that put itself back automatically because we weren't allowed to make any changes to the security group. So a Lambda function is watching logs and taking action. Okay, that's a little bit about Watch. I have CloudTrail running. CloudTrail is logging all kinds of activities in the account. I have private trails. This came in through the NIST confirmation template. So the NIST CFT also turns on some of these things automatically. And we can go in and see changes that were made and see the events in the event dashboard. We could also go in and look at CloudWatch logs. Config open access responder. Here today, we can see the logs. Let's see. Not all the logs are delayed by like 15 minutes or so like that, so it may not come in right away. I had that AWS S3 activity bucket, a couple different logging things that took place. I have that revert security group log, so that took place just a little bit ago. So I have Lambda function indicating that something took place. There was a rule that was added. Remember, I added IP address 1.1.1.1/32 on port 53 UDP in the security group, and it reverted it. I said, hey, that's someone other than the test account tried to make a change, and it logged it and notified me here in the CloudWatch logs that there was an issue that took place. So visibility into the misconfiguration and the change in the remediation that took place. I have AWS config running, so I'm watching pre-built rules about what's taking place in my account. I have rules saying, oh, I've got an IAM password policy, it's checking that I'm compliant. I've got read prohibited. I'm compliant right now. I wasn't compliant there for a moment until the script took care of that event-driven security change. The CloudTrail is enabled. I'm restricting SSH. I have a few things going well here, but I have a bunch of EBS volumes that are not encrypted. So it's telling me that here as a way to see that I have something I need to work on. I have Trusted Advisor running in the account. This is an easy way to kind of check, give you some best practices on security. I have 16 green check boxes for security, but I got one orange warning here. So maybe I go and see all the good things I'm doing. It is Friday after all, and I want to feel good before I go into the weekend. Hey, look, there's a lot of good things I'm doing here in the account. So I've got check boxes on most of these things, but there's still maybe some work for me to do over the weekend to fix this. This is what I haven't done. I haven't rotated my access key in more than 90 days. If I go over here to IAM, I'll find that even though I've rotated my password for this account, scott.hogg, I haven't rotated my, we'll see who the offending users are. My Splunk user also is greater than 90 days. So I need to get in there and rotate some access keys. I could put it off till Monday, or maybe I can do it this afternoon. So kind of a check and balance there, verification that I'm doing the right things and following security best practices. Trusted Advisor is free, so I encourage you to turn it on and run it. I also am running guard duty in this account, so AWS is kind of watching and doing things for me and preventing different types of attacks or letting me know that certain things happen. I had some unauthorized access to the console, a root user logged on. That doesn't look so good. That would have been a finding. So they give me some data about what happened. That this was actually, and then I recognized, okay, that is the IP address that I was coming from in my hotel where I'm at this week. So yes, that was me. Thanks for notifying me. I'm glad that it all checked out okay. But it's good to know these things. So guard duty only costs a few dollars per month for your account, but it's kind of gives you some other data visibility that only AWS has into your account. Okay, let's see, what else am I doing here? I'm running Inspector. I didn't want to pay for, let's say, Tenable Nessus. I'm going to have some built-in assessment templates, look for the CIS benchmarks and certain CVEs. I'm going to look for some runtime behavior analysis. I'm going to look for some security best practices. So I set up 3 different Amazon Inspector agents. I'm going to run them against Inspector targets, which is a set of hosts in the account based on tags. And I'm going to run these. And I've run them several times in the last days and weeks. And I can go in and see the run, and I can see the findings and say, okay, I have some stuff to do. I have an issue here that I need do something with an SSH daemon. I have a finding here. Also related to SSH, I have something else here. Again, with the SSH, permit root login, that's not allowed. Okay, I got some things I gotta do. In fact, if I go back to the dashboard, you'll see that I have 1,261 important findings. So I can go and look at all the things I have to do. Whoa, there's a lot going on here. It looks like I'm going to be busy this weekend. I have all kinds of stuff related to SE Linux. So maybe this can wait until Monday. Okay. So I'm running AWS Inspector. That's an agent built into my EC2 instances to do vulnerability scanning and different US practices as well. I'm using WAF and Shield. I'm using Certificate Manager. I'm using VPCs. I'm using Route 53. I showed you my S3 bucket security. I'm using secure EC2 instances. So I'm doing a bunch of good things in the account. There's a few other things that I could check. In terms of documenting the environment, I like using a little utility called Duo Cloud Mapper. Duo's a little utility that I can use to look at instances and get some data, kind of goes into your account, pulls data, creates an automatic diagram of the environment and the access. So I can see the account, I can see the sandbox, I can see the region I'm operating in, I can see the VPCs, I can draw pictures of the IP addresses that have access to certain things. So a pretty useful little tool. It's free from Duo. It runs, it's on GitHub. So Duo Cloud Mapper, if you're interested, shows you kind of a picture. We also use Cloud Checker. I have Cloud Checker running on this account. It's reading all kinds of configuration information and cost information from the AWS account. And it's giving me some best practices here for security. It gives me security, cost optimization, availability, usage. Shows me trusted advisor things that I'm doing as well. So another way to look for places where I can make improvements to the security of my AWS account. Okay, so I think we're at the top of the hour. I know I've shown everyone quite a bit of things. Are there any questions at the moment as we start to wrap up?
So as of right now, we've addressed all the questions, but if people have them, they can certainly ask.
Okay. Well, yeah, if you have questions, go ahead and ask them now. Okay. While people think of their questions, we'll go ahead and kind of summarize and wrap up here. So kind of to summarize, if you have good security hygiene on premises, it's likely you'll have good security operations in the cloud. If you have weak, undisciplined folks on premises, it's likely the cloud could be a disaster and could have quite a bit of an exposure. Cloud services can be more or less secure than what you do today. It depends on your disciplined approach and maybe level of automation, level of focus, and level of documentation and logging. You want to use automation tools whenever possible. So think about the Phoenix project and use those CI/CD software-driven techniques to help automate security and script it. So it just becomes the default minimum, maximum granularity, least privilege configuration. That's a great way to start out. You want to create accounts from the beginning with structure. So don't start out with a dev account with just the default VPC. You want dev, test, and prod to all look the same. So make them the same right from the beginning with some structure, using VPCs. Use the NIST CloudFormation templates. They're free. It's a free service. You pay for the resources that are procured in the account, but it gets you kind of started with some guardrails. You want to use many of the built-in security features that are available through low or no cost. rather than maybe try and build your own. It could end up being more costly because it takes more time. AWS has done some of these things for you that you can just leverage. You want to leverage these low, no-cost resources, use AWS free tier account to learn and test your security, leverage some of those low-cost things off the AWS Marketplace to test and see if some of those things, services and features and software could help you be more secure.
Oh, no, sorry.
Yeah. So here are some free security resources, some documents, some videos that I kind of look to on what are some of the best practices for AWS security. And always, you can use me as your phone a friend. If you need help, you can just reach out to me and I can point you in a direction, send you a document or share with you something I've done. Also, let me know if you're having problems or something like that. Maybe I can help you. Also, what I'll do is I'll provide a PDF of this presentation to your group so you can archive it along with the recording. So if you think back to, oh, what was that Scott guy saying about something about encryption, you can refer back to the PDF of today's presentation, and should be some links and some information that should help you after the fact, after today. Has anybody thought of any questions while I wrapped up?
Yeah, we had one come in. Can we extend the NIST compliant template to meet other compliance requirements such as GDPR or HIPAA?
Yes, AWS has those quick start templates. They have them for NIST, PCI, NIST really 853, PCI, and HIPAA. And if you look at those templates and you line them up side by side, it's like 95 to 98% of the template is the same. So you can definitely extend them. We've done some pretty amazing things using those NIST templates as a base. You can take the CloudFormation and break that apart and build out really complicated structures as you want, with many different public DMZs, many different application VPCs, different management VPCs. So you can use that as a jumping off point. If you know JSON or YAML, you can go in there and build your own templates that create your own architecture. And that architecture that you build can be used for your dev environment. Then as you move through test and prod, you can use the same structure, VPCs, for that whole lifecycle of application deployment. So definitely, they can be leveraged. The PCI, the HIPAA, and the NIST templates are 95% the same. So yeah, definitely I encourage that. Take those templates, break them apart, look at them. They're freely available to look at the scripts and build your own from that.
Okay, that answered that question. I'm not seeing any others right now, so I'll just thank you right now for this, Scott. This has been really great. I'll make sure I get this video and the slides posted when you send them off to me. And if there's no other questions, I think I'll end it.
Okay.
Thanks again for your time today. And everybody have a good weekend, and we'll talk to everybody soon.
Yeah, thank you very much. I've enjoyed it. Please let me know if I can be of assistance.
All right, thank you so much.